Hello, my name is Rick Chin. I'm the Director of Product Innovation here at SolidWorks, and I'd like to tell you about SolidWorks Sustainability. Now, over the past couple of years, we've all noticed how environmental concerns have become a bigger priority for many consumers. And this has created new competitive pressures for a lot of manufacturers and the products that they produce. And many of these manufacturers really are unsure of what kind of steps they can take to improve their competitiveness. So our priorities with the SolidWorks Sustainability product is to provide our customers with a very clear and easy way to be more competitive in this changing landscape by employing something called sustainable design. So over the next 15 or 20 minutes, what I'm going to do is show you the SolidWorks Sustainability product and show you how achievable sustainable design is. So without further ado, let me get right into the product. So in SolidWorks, I currently have an assembly opened up, and what I'd like to do is assess the environmental impact of one of the components. So let me just open that up. And the first thing I'd like to do is fire up the SolidWorks Sustainability functionality. So when that starts, it takes over our task pane over on the right-hand side of the screen. You can see we have a very simple user interface along with a dashboard along the bottom of the screen. Now, to determine the environmental impact of the product, we do something called life cycle assessment, and there's a handful of inputs that we use to do this calculation. So for starters, we look at the material that this part is made of. We can see that it's a plastic, and we have a choice of plastic, steel, aluminum, and so on. And then the specific type of plastic, and there are upwards of 30 different materials available. Now, these are the same materials that are found within the rest of the SolidWorks environment. Now, as we move down the user interface, we want to tell the system more information about this particular part and how it's produced, such as how is it manufactured. In this particular case, we're taking plastic and we're injection molding it, or another option would be to extrude it. If this were a metal part, we'd have options like milling, turning, casting, and so on. Down below, you'll see that we have two maps in the user interface. This is where we indicate whether this part is going to be manufactured in North America, Europe, Asia, or Japan. And then not only where is it going to be manufactured, but where is it going to be used. And this is important as we do this life cycle assessment. And again, just to recap what Jeff said earlier, when I do a life cycle assessment, I'm looking at everything that happens from when ore is extracted from the earth to the production of the part, to the use of the part by the consumer, and the final disposal at the end of life. And this is the information that we use to make that overall determination. So when we look at where in the world the part is manufactured, that takes into account things like the distance that the product needs to be transported, in this case from Asia to North America. In addition to that, energy or electricity is produced in different ways. We can do it with hydroelectric, nuclear, by burning fuels like coal and oil, and each of those have different environmental impacts. And when you look at how different regions of the world produce electricity, they'll use those different methods in different proportions, and the net result is each kilowatt hour of energy in one place has a different environmental effect than in another. And all this information is captured for you automatically inside of this tool. So we specified the part is going to be manufactured in China, used in North America, and down here we have our environmental impact dashboard. Great thing about this dashboard is it gives us real-time feedback on what the impact is of this part. We're measuring 4 factors here: carbon footprint, the total energy consumed, again, over that life cycle, something called air acidification, which is when we spew chemicals into the atmosphere, those that come back down in the form of acid rain, and then finally something called water eutrophication. And this is where, through agriculture and manufacturing, nutrients work their way into waters or bodies of water and eradicate all life eventually. Here within the dashboard, you can see the amount of each of these impact factors. In this case, we can see that we have just over 1 kilogram of carbon equivalents that are produced for the life cycle of this particular part. In addition to that, we have a pie chart, and this pie chart helps us to understand, given the decisions that we've made up above, how much do each of those decisions contribute to carbon footprint, energy consumption, and so on. So here we can see that the material choice that we've made contributes 37% to the carbon footprint. The manufacturing choice that we made, that this is injection molded, contributes 23%, and so on. One of the factors here that I didn't talk about is end of life. And we didn't provide an input for that, but based on the information captured in the database that our partner PE International gave us, we're able to determine based on the size of the part, the material it's used, the material it's made from, and where in the world it's used, they can tell us what percentage of that material is recycled, ends up in a landfill, or is maybe incinerated. And again, that goes back into this calculation. The cool thing about the dashboard is, again, it updates real time. So as I make changes, so maybe rather than manufacturing this part in North America, let's manufacture it in Japan. So I'll click that in the map, and you can see the dashboard is updating to reflect the fact that, and I'll focus on carbon footprint for this demonstration just so we have one particular thing to talk about, but the carbon footprint has gone from just over 1 kilogram to 0.86 kilograms. So we've made an improvement. We can see that reflected by this green bar. Now, is 0.86 kilograms good or bad? And that's really hard to know. So one of the important ways that our customers are going to use this particular product is they're going to incorporate something called a baseline. And so the idea here is, let's take a previous design or a previous product, let's measure its environmental impact and put a stake in the ground for that. And now as we work on the new design, we can set as a goal for ourselves, well, let's reduce the environmental impact or the carbon footprint for this next product by 33%. And we always have this baseline to refer back to in real time as we work through the design. So for example, let's again change the manufacturing region. Since this part is going to be used in North America, let's manufacture it in North America and see what the net effect is. Okay, so when that updates, we can see that we've drastically reduced the carbon footprint for this particular part, given its particular size, material, and so on. If we want more details, we can click on any one of these boxes in the dashboard, and we can get more detailed information on each of those environmental impact factors. So again, for carbon footprint, we can see that the use and transportation was significantly reduced from a carbon perspective, but at the same time, our manufacturing actually produces more carbon in North America than it does in Japan. And we can look at each of these. Again, energy consumption, air acidification, and water eutrophication, and get a good sense of what's going on from an environmental standpoint with our product and the decisions that we're making. Now, other changes I might want to make might revolve around my material choice. Now, materials are important not only from a sustainable design standpoint, but they're important to every single SolidWorks user, and they all have to make considerations around it. We built this great tool called Find Similar. Now, if I wanted to change the particular plastic that I'm using for this design, I might want to change from this ABS polycarbonate blend to one of the other material choices that I have. And I have about 30 plastics available here. But rather than going through these one by one, how do I know which one mechanically will meet my criteria for the design and be more environmentally responsible? So one of the cool things that we've done here is, again, created Find Similar. So what this does for us is it allows us to search the database based on what we think is important for the alternative material that we're looking for. So I'd like this next material to, again, be a plastic. I want it to be lighter than the current plastic that I'm using. And you know what? In tension, I want it to be stronger. And then we'll have the system search the database based on those mechanical priorities. And instead of having 30 materials to evaluate, I have 2 that I know meet my mechanical requirements for the design. Cool thing is, when I select on a material, you can see the dashboard update to reflect how this new material compares to the old one. So I can look at the green bars and I can see, okay, this material is marginally better and actually worse in terms of energy to the original ABS polycarbonate blend. How about the PPE plastic? When I select on that, I can actually see it's notably better on all environmental impacts. So that's the material I want to go with. So we'll accept it. We can see the dashboard down here, update to reflect that change, and on we go. Now, the dashboard is a great tool for communicating in real time what the environmental impact is of this design. But as I'm doing this, there's other people in the organization I'm going to want to communicate with on what we're doing from an environmental standpoint. And that's why we've created the ability to generate customizable reports inside of the tool. The neat thing about this is it'll take all that information and present it in a way that reflects very professionally and compellingly on the work that you do as a designer. Now, as it's generating a report, the other thing I want to mention is these reports are customizable. So you have the opportunity to embed your company logo, company information, and your contact information as the SolidWorks user, so that every time a report is generated, your information is presented there each and every time. Okay. So what I'll do is let's just look at the report that's generated. Again, it's taken the logo for the company that this food processor is being produced for. Again, the contact information for the company and the engineer. And then it automatically fills in information such as an image of the model, stats on the design. Again, the information I put inside of sustainability, such as where this part is going to be manufactured and used, which in this case is North America on both accounts. Then we can see our environmental impacts in terms of the dashboard information, so we can see the pie charts and the total environmental impact on each one of those fronts. If you specify a baseline, like we did in this particular design, right, I'm comparing it to a previous design, right, we can see that baseline information as well, its input parameters, and just as importantly, how the baseline, which is shown in black, compares to the new design, which is shown in green and red, okay, in these graphs. Now, since this is a document that's probably going to go to other people in the organization that really don't know anything about sustainable design, what we've done is we've added more information to make this a document that really stands on its own and is useful to a lot of people in the organization. So we've included a graphic to explain what life cycle assessment is, along with a glossary of terms to make this a very, very useful document for many people. Okay. So what I've been showing you so far is Sustainability Express, and that's a product that allows you to do this life cycle assessment on individual parts. And this is the product that's going to be in every single seat of SolidWorks 2010, so that every SolidWorks user has the ability to assess the environmental impact of their designs from a part perspective. Now we can take this another step further and look at the full sustainability product, which allows us to analyze assemblies. So you'll see that there are some additions that have been made to the user interface. One of them is now we can tell the system, well, as we're transporting this part from one place in the world to another, or in this particular case, the assembly, what's the method of transportation? Is it being sent by train, truck, ship, or air? And each one of those have environmental impacts of different magnitudes that you can take into account. In addition to that, again, this is a complete life cycle assessment. So you're looking at everything from cradle to grave, which includes that time that's spent by the end consumer using your product, which in this case would be a food processor. Well, as a part of doing that assessment, one of the things that you want to look at is how much energy is consumed during the use of that product. So the full version of the product lets you specify what type of energy is being consumed and how much. And so, well, one of the things, again, if we look at carbon footprint, we can see transportation and use accounts for about 40% of the carbon footprint for this assembly that we're looking at right now. But when we add in the use phase energy, which again is 5 kilowatt hours here, okay, we can see it actually goes up to about 63%. And again, we can see how that relates to all the other contributions to environmental impact, like the material choice, the manufacturing process, and so on. Okay, so again, it's a lot of really actionable, useful information that we can provide the user about the total environmental impact for this particular product that they're designing. Now, as we look at the entire impact of the product as a whole, right, one of the things that we want to do is make this product very actionable. Right? I want to reduce the environmental impact of this product, but where do I need to focus my energy? Which of the components here is causing me the most heartburn in terms of having the largest environmental impact? So there's a great way to look at that called assembly visualization. This is a new piece of functionality that's being added independently of sustainability to this release of SolidWorks. And the cool thing about assembly visualization is it allows you to control the display of the components in your assembly based on properties like, in this particular case, weight. So it's sorted the components from heaviest down to the lightest. And one of the cool things is I can control the visibility. So I can do things like, well, let's hide all the lighter components so I can see which ones are the heaviest in my assembly, okay, if that's an important consideration for me. So why is this important to sustainability? Well, we can actually expose not only standard properties, okay, but the environmental impacts that we calculate in SolidWorks Sustainability. So I can do things like I can say, well, you know what, I want to look at the total carbon footprint for each of the components inside of my assembly. So when I do that, I will again sort, and I can see my components listed from those with the highest carbon footprint down to those with the smallest carbon footprint. I can control the display. Like I said, I can hide and show particular ones. What's even cooler is I can control the color of the components. Let's make it so the ones that are the greenest are truly green, right? And the ones with the worst environmental impact are red. And I can modify this gradient as much as I want to make it even clearer what's going on in terms of which components are good, right, and which components are bad. And so I can see the 3 or 4 components in my assembly that I really need to focus my attention on right now to improve the overall environmental impact of my product as a whole. So that's SolidWorks Sustainability. I hope that I was able to show you in this very short period of time how easy it is to use SolidWorks Sustainability and to make sustainable design a part of your design process. Thank you so much for your time and attention, and I hope you enjoy the rest of the event.